They were okay, okay. We thought that they were going to continue revising, okay. And now it's 2 minutes past 8. I wish that you are, let's say, joining your lecture, okay. And yes, last night I gave one exercise. I told you that please try to do it at home. Then we're going to do it at the same time, okay. I will share, let's say, my screen, okay. Just a moment. Window. Okay, entire screen. Okay. Okay, entire screen. I will try to reduce this one, but I don't know if it's possible, not possible. Okay. Now, learners, we told that we are going to solve, let's say, an exercise dealing with complex numbers. Okay. And this exercise was given for you yesterday or last night. Okay. I'll just inform you that we are going to continue revising. I will send you the link. Okay, now I'm online, let's say on Twitter and Facebook and YouTube at the same time. Okay, so if it is possible, try to join your lectures. Okay, learners, it's very important for you. Okay, very important for you. Okay, I'll just share this one. Okay, Facebook. I'll share this one first of all on Facebook. Join your Pioneer. Join your Pioneer in Math. Okay. Murad. Sultan Ezouidi. HSM. Okay. Okay, share this one. I will share this also for your groups. Okay. WhatsApp. Okay. Go there. What exactly here? This one and this one. Okay. Try to do your best. Okay. Your best and continue revising online, revising. Okay. Try to join, it's better. Okay, try to join. Okay, to join your Pioneer Math, your Pioneers in Maths. Okay, their vision was a start. Their vision, okay, the main revision or their vision for preparing you for the vision for preparing you. Okay, you for the final exam, for the math final exam. Okay, I was here to help you. Okay, now learners, just I told that we are going to continue. Okay, we let's say go back to the question. Okay, the question is dealing with complex number. I thought. Okay, complex number. Where is it? Okay, which that's here or okay. This one, yes. This is the exercise that we told that we should do it. Okay. Therefore, I just need, let's say, this one. Okay, copy. Now, learners, I'm going to solve this question. Okay. And this question was given for you last night. At least you thought you, at least you tried to do it. Okay. And I told you that 8 o'clock I should be online. Okay. So that I can help you. Okay. Now, learners, I will just write the question is given Z1 is a complex number such that the modulus of Z1 is 1 and the argument of Z1 is 2 pi over 3. Okay, and this argument should be, let's say, more than negative pi and less than pi. Okay, So to start, let's say writing, let's say Z1 in terms of x plus iy, we are going to proceed like that, learners. Okay, okay, we are going to do like that. Let's see the question. I'll put it here. Okay, so you can see it. The question is clear. I will now try to work with you at the same time. Okay, so this is my complex number. Z is should be written as x plus iy, where the modulus is 1 and the argument of z is 2 pi over 3. Therefore, learners, to start solving, I will just write z1. Okay, I will write it here z1. This one is in fact equal, in general, is equal to z1. I told. Okay, this is z1 equal ikr exponential of I argument of z. Okay, exponential I of argument of z. This is the argument of z1, of course. Okay, I'll put it here. This is definition. Okay, it can be written also as in terms of theta. Okay, so but you know the argument of z is 2 pi over 3. Therefore, I will, and you know that the radius in fact is equal to what, learners, is the modulus of z, which is equal to 1. Okay, therefore I will write this as that. Okay, I will copy this. Then this is in fact is equal to r, which is 1. In fact, the modulus of z1. I will write here the modulus of z1 in general. Okay, so that we can be confused while solving this kind of questions. This is, let's say, the main important thing, that z1 equal the complex number is r exponential I argument of z1, which is equal to the modulus of z1 exponential of I argument of z1. Now what we are going to do exactly, we are going to replace argument of z1 by 2 pi over 3. Therefore, learners, I will just write this as that. So this one will give me exactly, okay, this will give me exactly the following. So r now is 1 multiplied by exponential. No need to, okay, you can write here 1 multiplied by exponential of I argument of z is the same. But here I should replace what exactly? I should replace argument of z by 2 pi over 3. Okay, this is known as the argument of z, which is 2 pi over 3. Now try to convert this exponential form to polar form. The polar form should be equal to r exponential of argument of z1 plus r cosine of exponential cosine of argument of z1, which is 2 pi over 3, plus I times r sine of argument of z1, which is 2 pi over 3. Just I will write this as that. And r here is, let's say, 1, so we can write it as that, cosine of 2 pi over 3, okay, plus what, learners? Plus I, brown, don't touch, no, brown, plus I, okay, plus I, control sign of, okay, I will close this one, sign of my argument. Okay, then the rest should be erased. Okay. Okay. I'll just erase this one if it is possible. Okay. Now learn, this is my complex number z. Okay. And the question is, just let's say write your complex number z1 in the form of x plus iy means in the form of polar form, and this one is called polar form. But you are going to find the value of cosine of pi of 2 pi over 3. Okay, so every one of you has his own calculator. Try to convert, let's say, 2 pi between parentheses. I can convert this as it will be 2 times 60, it will be 180. I will just write again, it will be equal, which is equal to what? Cosine of 120 degree. Okay, 120 degree. Why? Simply because 2 pi over 3 is 120 degree plus, okay, plus I times sine of 120 degree. Okay, and you are going to use a calculator. Okay, you will try to find this as that. Okay, so this one learns in fact is equal to 100 and cosine of 120. It is in the second quadrant, so should be negative. Okay, cosine of 120. Okay, it will be negative equal to, okay, I'm sorry, okay, equal to negative half. Okay, this is the first step. Should be equal to negative 1 over 2. Okay, negative 1 over 2. And you already know that sine of 120, 120 in the second quadrant, sine is positive. So I will write minus 1 over 2. Okay, plus what? Plus learners. Okay, I will tell this symbol of fractions. Okay, like that. Therefore, sine of 120 learners, it will be root of 3 over 2. Okay, sine of 120, it will be root of 3 divided by 2. I will just write here 2, and here I will write root of 3. Okay, Barham, come on, please. The 4 learners, okay, and now I just wrote my, let's say, complex number z1 in terms of x plus iy. Okay, here multiply by what, learners? By I. Okay, so this is in fact your complex number should be written like that. Okay, and make sure that Barhum, come on, make sure that let's say your complex number is exactly negative half plus root of 3 divided by 2i. Okay, now if you want to just, let's say, to check, okay, you will just make like that. Okay, first of all, you are going to find the modulus. If this is z1, you are going to square minus 1 over 2. I'll just write it here if it is possible. So I'll make copy. Then I will just put this there. Okay, I want to use this. I'll just first of all fix this one. So so that to explain this again, okay, this is z1 should be equal to what? In fact, equal negative half plus root of negative half squared. Okay, plus root of 3 squared. Okay, so I'll just write like that. I will make go here and I will insert this one, exponential of what? Okay, I will make control V, then I will erase this one. Okay, no need. Okay, I will close this one, then to the power 2. Okay, of course here there is a root of. Okay, I will make root of, then I will put this here. No, okay, I'll just take this one. Okay, erase this. I will make root of First of all, we told minus 1 over 2 all squared. You should square the first three numbers. It will be between parentheses minus 1 over 2. Okay, all squared. All squared. Okay, close the parentheses. Then what else? Then here you should square this number. Then plus, I will square the imaginary part. Plus what, learners? Plus, okay, root of 3. Root of 3. Root of 3. Okay, this is root of 3. Then I will subtract this one. Okay. So this one is equal. No, but come on. This one, in fact, is equal to what? I will make it small, or I will make it bigger. No problem whatsoever. Okay. Okay. So this one will give me exactly, learners, that the following. Okay. Minus 1 over 2 squared is 1 over 4. I can write it here. 1 over 4. Okay. 1 over 4. Okay, I will just erase this one, and this is 4. Then plus what, learners? Plus exactly root of 3 squared is 3 divided by 4. Okay, I will just put it here. Plus, we told the root of 3 all squared is 3. Then 2 squared is 4. Okay, square is 4. Then I will erase this one. So we can see this one, learners. In fact, okay, no problem. I will make 3. Okay, plus 3 over 4. 3 over 4. Now 3 plus 1 is 4, and 4 divided by 4 is 1. Therefore, root of 4 divided by 4 is root of 1, which is equal to 1. Therefore, Z1, now the modulus of Z1, in fact, is 1. Now we're going to check about the argument of Z. Okay, I'll just make like that. Okay, the argument of Z, learners, means that you can see this negative half, and this is the root of 3 divided by 2. The real part is negative, and the imaginary part is positive. So I will just make like that. It is possible. Okay. No, Brad. Just what you know. Just one paper or 2 paper. Okay. Thank you. Or the writing, as you like. Now I'm recording the lecture, Brad. I'm recording the lecture. So therefore, we told that I will now express this in, let's say, in the Agrand diagram. Okay. I will use this one, or I will make, okay, I will use it. Okay, a fan in it. Then I will go to paint. Okay, where is paint? Paint, okay. Okay. So here we told that we'll just, okay, plus this one. I will cut out of this. No, just a moment. Okay. I will just now cut this one, no need. Okay, don't relax. Then I will draw my Agrand diagram. This is the Agrand diagram. Okay. This is, it's called real part. This is the real part, and this is the imaginary part. Okay. So, real part, imaginary part. Or I will just write it. Okay, I will write with this pencil. Okay, imaginary part. Okay, imaginary of Z1. Okay, and this one is real Z1. Okay. Now, learners, I will just plot this complex number on my again diagram. This is 0. Okay. Therefore, this is, I will suppose this is minus 1 divided by 2. This is minus 1 divided by 2, and this is root of 3 over 2. I'll just put this number there. Okay. This is minus 1 over 2. I put it here exactly. And this is root of 3. Okay, the imaginary part of the complex number. I will put it like that or like that, whatsoever. Okay. And here I will write this again, or I will cut this first. And this is no need. Okay. I'll just write what exactly. This one is the imaginary. The y value here is, let's say, denotes or represents the imaginary of the complex number z1. Okay. Now you can see that, in fact, there is an angle, okay, occurs between the x-axis and the real part means and the terminal side of the angle. Means like that, learners. I'll just suppose this is my angle. Okay. Or I will make, okay, I will make a square here. Then I will, okay, this is the square. Okay, the angle is here. Now just I will cut this. Okay, this is no need. I need only the point that I'm looking for. Okay, now learners, you can see that this angle is in the second quadrant. Okay, so this is theta. Okay, and this is the argument of z. Okay, this is the argument of z. In fact, let's say here is 120 degree. 120 degree in terms of radians should be equal to 2 pi, okay, all divided by 3. Okay, above, خلاص. So now it's clear that the argument is 2 pi over 3. That's why here is written 2 pi over 3. Clear? I wish that's clear for you, learners. Okay, I'll just okay, cross this one and then make it smaller. Okay, like that, no problem. So this is, in fact, the how can you, let's say, draw the Agrand diagram in your the complex number, sorry, in your Agrand diagram. Okay, now just put it here, enter. Okay, I will make my Agrand diagram here. Then I will make it small so that it's easy for you to collect all the additional information that we already explained. Okay, now just this one, I will put it here. Is possible, of course. I will see if it's clear or not. Okay, so I put this down first. Go down. I'll cut this. Okay, cut. This is the question. Okay, this is the question. And this one is the how can you show your complex number on the Agrand diagram. Okay. Now learners, it's clear at least how can you, let's say, find or write Z1 complex number, okay, in terms of x plus iy means polar form. Okay, so this one, it's called polar form. Okay, this one is polar form, and this is called exponential form. Okay, I'll just like make like that. Now we move to the second part, which is if, let's say, the complex number z1 is given now as what exactly as minus half plus root of 3 divided by 2i. Find the argument of z to the power 3. Here, learners, in fact, there is a formula you can use. Okay, to solve this one, I will make enter. Sorry, I will make enter. Okay, I will make like that. Brown, come on and sit, please. Papa. Okay, this is my argument of z. Z3, I'm looking to find what's its exact value. Therefore, did you remember that? I'll just put this here if it's possible. Okay. I will, I mean, this one is equal. Try to find, means find the z argument of z1 to the power 3. Means, in fact, that there is a formula. This one, learners, is equal to 3 times equal 3 times what? Argument of z1. Argument of z1. Okay, this is the formula. Okay, argument of, between parentheses, if you like, z1. Okay, therefore, argument of z1, learns that is equal to 2 pi over 3. So this one equal 3, okay, times 2 pi over 3, 2 pi over 3. Okay, so you can cancel, let's say, the numerator value and the denominator value by the common factor. 3 by 3 is 1, or 6 pi over, let's say, 3 gives you exactly 2 pi. Therefore, this one is equal to 2 pi. That is pi, this is pi. So this is the argument of z to the power 3. If we suppose that, now learners, the question is looking for, let's say, if we suppose that the question is looking for you to find the argument of z to the power n, for example, there is a formula. It will be n times, be careful below, n times argument of z1. Okay, and it will be, let's say, n times 2 pi over 3, because here now the whole play with this, because the argument of z here is 2 pi over 3, which is equal to, okay, 2n pi divided by 3, which is equal to 2 times n, because n times 2 is 2n, pi over 3. So don't forget about this kind of questions. Okay, this is the first method. Okay, and this last one is the general method. If argument of z1 is given, so the argument of z1 to the power n, okay, the n's here, it will come like that. It will come in front of the argument of z, means you are going to multiply your original argument by this index, or by this power. This is first method. Okay, first method. First method. Okay, we have another method also, learners. Okay, I will just explain this to you here. This is called its first method. Okay, 2 points. Now we move to the second method. Okay, this is a formula, notes. This is notes. Okay, don't forget about this, it's very important. This is a note. Okay, and in general, if we suppose to write now to cancel 2 pi over 3, okay, you are going to write yes, this one. I'll just now cancel the rest. No need. Okay, so, okay, I will cancel this one. Okay. Now this one, learners, is a formula. Don't forget. Okay, whatsoever, let's say, the complex number and whatsoever the power here. Okay. Now I will use my complex number z as z1. Then I should, let's say, raise it to the power 3. And then I'm going to see what will happen. So this is z1 is equal. Okay, like that. Round play, please. حبيبي أنا تفلز أنت زيادة من هو أحسن أنت حبيب باباتو هاي حق. Okay, I'll put this here. Now we told the next method. Okay. Okay. I'll just write this one. I will extend this. I will now try to make z1 to the power 3. Okay, I will. This is z1, therefore, this will give me, if I'm going to raise this to the power 3, I will obtain that. Papa, I will obtain what? I will just use this one. It is possible now, it doesn't work. I will make, okay, I will copy only this one. So I'll just write here exponent. Okay, exponential of, we told z1, okay, to the power 3. So as here we raise it z1 to the power 3, you should also raise this to the power 3. This one learned is equal to, okay, equal to, we told that exponential, okay, up is 3, because you should raise this one to the power 3, which is equal in fact to exponential 2 pi over 3 between parentheses, of course. Okay, and let's say you see 3 times 2 pi. I will multiply this index by this one. So this one is equal to exponential. I'll make exponential 2 pi multiplied by 3 is 6 pi. Divide by 3 gives only, or I will write it, no problem. 2 pi, this one, 2 pi multiplied by 3 is 6 pi. I will write 6 pi. Divide by 3. And 6 pi divided by 3 learns is what? Is equal to exponential 2 pi. Exponential 2 pi only, because the 3 is a common factor, it will be cancelled out by k. We'll make like that. Okay. Therefore, now learners, this one is written as what exactly? Is cosine of 2 pi, which is the argument of z1 to the power 3, plus I sine the argument of z1 to the power 3. And we figure here that in fact in the first method, that argument of z1 to the power 3 is 2 pi. So choose one of these methods. Okay, therefore this one is equal. Okay, this one is equal in terms of exponential form. So we got the argument of z as a conclusion. Argument of z is z1, of course, or argument of z1 to the power 3 is 2 pi. Okay, therefore I'll just write here. Therefore, where is it? This one. Therefore, argument of z1 is I will make z1. Where is z1? This one. Copy. Z1 is equal to pi. Okay. Or let's say 3 times argument of z1 is equal to pi. Okay. Copy. Now, learners, if you are going to use the polar form, okay, you will make like that also. This is z1. I will use this. So, I will make a paste, then I will write this as that. This is now first method, and this is second method. Second method. Second method. Okay. Second method. 2 points. Okay. I will just make it small so that I can. 18, it's a lot. 14, it's okay. Yes, okay. Now learners, third method now. I will just write the third method. Okay, this is third method. Third method. I will just suppose that Z1 is equal to exponential, 2 pi over 3. Okay, which is in fact equal cosine. Okay, the modulus is 1, so no need to write it. Cosine of what? Of 2 pi over 3. Of 2 pi over 3. Okay. That's what? Plus I multiplied by the modulus is 1. It will be I multiplied by 1. It will be I sine of what? Sine of pi over 2 pi over 3. Okay. Now, learners, I want to raise Z1, let's say, to the power 3. It will be equal to, okay. أنا hello Sonia في سعادة جاي هيك okay جاي. Therefore, I will make here this one is equal to what? In fact, copy. So therefore is equal. I will make like that. Then I will take cosine the polar form here. Okay, I will plot it here if it's possible, of course. Okay, now you know that De Moivre formula, this exponent should be multiplied by the argument. Okay, so this one, I will just write this again. This is very important. Okay, I will make small if it is possible. I will make it small so that you can see it. 12, okay, 12, okay, that's it. Therefore, it was that. So this one is equal to what? Okay, I will make this one small. Okay, now this 3 learners, this 3 should be multiplied by the argument. So 3 multiplied by 2 pi, divided by 3 is 2 pi. I will just write here 2 pi exactly. Okay, and then here divide by 3, the 3 will cancel it because common factor, and this is also okay 2 pi. Then I will erase this if it is possible, of course. Now as I let's say expand this, let's say De Moivre formula told that cosine of x plus I sine of x all to the power n is equal to cosine an x plus I sine an x. Okay, so that's why the head is multiplied by that. Now I will write this is the last answer. Okay, I will now cancel this one, the 3 class, because it's already raised. So this one, in fact, learns cosine 2 pi is 1, sine 2 pi is 0. Okay, so it will be 1 plus I times 0 is 1. So this is, okay, this is learners express or give you a slight idea about Euler formula, which is exponential ix is z. Okay, and I wish that's clear for you, okay, learners. And here it's clear that the argument of z1 to the power 3 is 2 pi. Thank you for listening. See you inshallah next time, and goodbye. Okay, I'll stop sharing here. I will just okay, I will collect this. This is now it. Don't save. Okay, thank you for listening, my best learner. Now I'm going to end the streaming. Thank you, goodbye. I wish that's clear for you at least. Okay, we can hear inshallah tomorrow and after tomorrow and so on. Thank you.